Okay. So my name's Forbes. I run training workshops in React, Node, that sort of thing. I'm also going to start my own business soon, and I used to work at Facebook in ads. And today I'm going to be talking about end-to-end testing with a specific focus on React applications. So hopefully a lot of you are familiar with this kind of testing pyramid idea where you have a lot of unit tests, a slightly smaller number of integration tests, and then a much smaller number of end-to-end tests. Now, the problem with this model is it's really hard to get that true perfect pyramid, because this is assuming that you write thousands upon thousands of unit tests and get 100% coverage with your unit tests. And if you don't, this model kind of breaks down. So I prefer this model, which is where we change a bit how we're looking at things. We're not just talking about testing now, we're talking about everything that contributes to code quality. So that's including static analysis. So the great thing about static analysis is straight away 100% code coverage of static analysis. Then we've got JavaScript tests. I really don't see much point in differentiating between unit tests and integration tests. They're all just automated JavaScript tests. And for the most part, the only reason to mock stuff is either to make your test more reliable or to make it run faster. So for the most part, you should be writing, I think, tests that are not true unit tests, that are more like integration tests. And then at the top of the pyramid is still end-to-end tests. This is the number of tests that this pyramid is representing, but what it's not representing is the importance. The importance looks much more like this. We need all of these parts of this stack if we want to build really reliable applications. They're similarly important, they catch similar numbers of bugs. It's only really the number of tests that is that pyramid shape. So why static analysis at the bottom there? I've already said covers 100% of the code. If you're using some kind of type system, it can provide a certain amount of built-in automated documentation. It catches really silly incorrect assumptions where you think something's a string but it's a number, or you think it's a number but it's a string. And it catches those assumptions even if the code is still working, which can be really useful for making sure your code stays maintainable. Because incorrect assumptions mean that when you change code, you're really likely to break it, even if currently it still works. So this helps make refactors much safer. The limitations, though, is that it doesn't enforce intent. There's nothing about, no amount of static analysis will check that the code does what it's supposed to do. It'll check it doesn't crash, and it can check for certain obvious mistakes, but it can't check that that code does what it's supposed to do. It can check a function takes a number and returns a number, but it can't check that function doubles the number. It doesn't actually run the code, that's the issue. So if you want to do static analysis, ESLint or TSLint, if you're using TypeScript, allows you to specify a list of rules that catch common mistakes, common failings. Then next up there is TypeScript and Flow. Both TypeScript and Flow are static type extensions to JavaScript. They're not massively different to each other. Some people claim that TypeScript is like a completely different language. It's not. It's just JavaScript with some extensions, exactly like Flow is. They really are virtually the same tool, just different implementations. What neither of these things are for, what none of these things are for, is checking that your code is formatted correctly, checking for white space. Don't use these tools for that. If you're using these tools for that, that is a mistake. If you want something for that, use Prettier. Prettier is awesome. Everyone should be using Prettier as soon as possible. Okay, next up, JavaScript tests. Much faster than end-to-end tests. That's the main reason we write them. Second reason we write them, they're reliable, they're consistent. Because you're not talking to databases, you're not relying on web browsers and all of that sort of thing, they don't tend to just fail for no reason. And the other advantage to them is that you can isolate problems really well with JavaScript tests. Because you're testing only one part of the application, and often you know it's like these inputs go into this component, and then these outputs should come out. It's easy to tell where the failure is when you get an error. Downside, it doesn't test the actual platform. So if like your web browsers change and they add some new API or they break some old API, these tests aren't going to pick that up. You need a lot of tests to get good coverage. It helps to avoid mocking things out and avoid trying to do these like microscopic unit tests. But you still need a lot of integration tests, a lot of JavaScript tests before you get good coverage. And it doesn't tend to test the integration between front end and back end, or the integration with databases, or anything like that. The other thing is, you're not testing what the user really does. It's great if you're testing like an API and your users are developers and they're going to be writing against the API. But most of us day to day, we're building apps, and the users of our apps aren't like calling a function, like firing off Redux actions. They're sitting there clicking on buttons and typing text into boxes. So if you do want to do JavaScript tests, Jest is currently the best in class by a long margin. So I recommend using Jest for automated tests of that nature. So end-to-end tests. Why end-to-end tests? That's the whole point of this talk, really. They let you test what a real user would do. They help you expose browser inconsistencies. Once you've got a good end-to-end testing stack set up, it's not that big a step from there to running it on all of the different browsers that your users use. And then you can pick up where, 10% of our users use Safari, but our site is broken in Safari. That's 10% of users getting a broken experience. A relatively small number of end-to-end tests can cover really big parts of our application, because you do one flow through your application. You're not testing like this component and then this component. You're testing the whole stack at every stage. You're testing the full integration of the app. And it's really the only way to know that part of your app works is to have some kind of end-to-end test, whether that's automated or manual. If you're not testing the whole flow, you don't know whether it works. Limitations are that end-to-end tests tend to be very slow. They tend to be unreliable. They can be expensive to run. Like there's cloud providers for providing the browsers, but they're relatively expensive. And it's hard to know what caused failures. So on the last point, hard to know what caused failures, my argument here is that that isn't the point of your end-to-end tests. Your end-to-end tests are not there to tell you what failed. They're there to tell you that something failed. And it's then your responsibility as a developer to go in and debug what's failed. Hopefully, 80% of your tests will be, 80% of your bugs will be picked up by a combination of reading the code, static analysis, and JavaScript tests. And that collection gives you enough information to pinpoint those bugs. So this is really about the last 10, 20%. And those are bugs you wouldn't even know existed if you didn't have these end-to-end tests. So if you don't know exactly where the bug is, then that's a shame, but it's still worth doing this work. We can do a lot to improve the unreliability of it. The speed is getting better and better. And there are options that don't require you to use any of the kind of big Selenium grid cloud providers. You don't need hundreds of servers to get started. You only end up running into those kind of problems when you're trying to test across a broad spectrum of browsers. If you're happy to just run your end-to-end tests in a single browser, as I'll show you in a minute, you can do it very easily. So, what's the technology we're going to use to automate our browsers? Well, Webdriver, according to the documentation, is a remote control interface that enables introspection and control of user agents. It provides a platform and language-neutral wire protocol as a way for out-of-process programs to remotely instruct the behavior of web browsers. That was a mouthful. What they mean is, it's a consistent API for automating web browsers, which is exactly what we're after. So this provides a REST-based API, a JSON API, for automating all of the different web browsers. Virtually every web browser supports this. And they support it pretty consistently. And it now has a really good specification maintained by W3C. So you can go and you can find this document, and it is pages and pages and pages specifying in minute detail exactly what this API should do under each circumstance. And this is an API that is supported fairly consistently all the way back to like IE7. So you can go and you can automate really old browsers with this. I did see something, I forget the name of it, but there was like one of those old text-based browsers that used to run in like the terminal. And I think Source Labs added support for that a while back. But not particularly useful because it doesn't run JavaScript or anything. Anyway, so if you want to run tests across all the different browsers, the easiest way to do it is to subscribe to one of the plans from one of these cloud providers. I've personally tried Source Labs, Browser Stack, and Testing Bot. I haven't tried cross-browser testing myself. My experience of these is that they all seem to provide almost exactly the same service, so my recommendation is pick whichever is going to end up cheapest for your workload. But they all work pretty well. And they all provide you with a really easy way to get set up and go, I want this version of Chrome, this version of Internet Explorer, this version of Firefox, run my tests against all of these. But you can write your tests, because we're writing against this Webdriver API, you write your test once, you can change provider. There's nothing that stops you changing provider if you're using just normal standard Webdriver APIs. What about running locally? Sorry. What about when you don't want to pay some cloud provider to run your tests, you just want to run locally on your machine? Well, there's this awesome project called JS DOM that's maintained by Dominic Denicola, which is a full implementation of the HTML DOM standard in pure JavaScript. So you can run this in Node, you can even like bundle it up and run it inside another browser. And it's a complete implementation. It even has support for things like the Canvas API, although that does require a native component. But it's not a full browser. It has limitations. And if you want a full browser, you need to add something to it. So I built a project called TaxiRank. And TaxiRank wraps JS DOM and adds support for navigation, although that is going to be backported into JS DOM soon. But more importantly, it adds a WebDriver interface for JS DOM. So it's exactly the same interface you'd get with a real browser, and it gives you effectively a full headless browser that runs in process in Node.js. Now, the WebDriver API is a REST-based JSON API, as I've said, and most of the time that's not the way you want to code. So there's lots of clients for this that you can choose. I've written Cabby, which is my own, and it's just a wrapper around that JSON API. The nice thing about Cabby is it provides an asynchronous and a synchronous interface, so you can choose if you want to be running loads of tests in parallel and you want to avoid the overhead of multiple node processes, you can use the promise-based API. Or if you want to just get a test written and working as quickly as possible, then if you just use the synchronous API, it's just easier to write code that's synchronous. Okay, enough talking, time for a demo. Okay, so I wrote an application a while back that is is this working? Yep. I wrote an app a while back that is a web app for taking entries into canoe slalom competitions or kayaking competitions. And it has an end-to-end test, and this is going to run through a whole load of stuff. What it starts out by doing is actually running a load of SQL, because it's got to get the database into a consistent state before each run. So it's got to create the users that are going to be used in the test. It deletes users from old test runs at that point as well, so that I don't just keep expanding the number of records in a database. It just creates that consistent state so that every time the tests run, we're getting the same thing. So this is going through, it's logging in as one user, like creating an event, logging out again, logging back in. But all in all, it doesn't look very impressive when you're just looking at this terminal output. This is just the output from Cabby and then the debug logs. But what we can do is run this. That was running in taxi rank, this fake browser. But we can go and start Chrome driver, and we can run the exact same test. But now what we're going to do is we're going to tell it to run with the remote set to Chrome driver. And it's going to run in a real browser, and we'll be able to see it go through the whole process in real time. In a moment. So it's loading up the application, it's logging in. The approach to take for logging in with test users is to remember that you have like raw access to the database. So when it comes to like dealing with things where you need your test to do something that the UI doesn't really support, don't punch holes in the security of your application. Just have your test directly connect to the database, do what needs to be done. But this is running through this test way quicker than I could manually, but that's not really the point. The point here is that I don't normally sit and watch this. Normally it just happens as part of the continuous integration step, and I can forget that I'm doing this until it breaks. And that's the key. I would never in a million years be bothered to run through all of those steps for every single change I make to this system. Because 9 times out of 10, I'm like, I've made this change on this page. It's not going to affect any of the other pages. I've tested this page and it works. But maybe 1 in 10, maybe 1 in 20, I don't know. But from time to time, I'm wrong. And that change I made over here works fine on this page, but it breaks that other page that I didn't think would even be affected. And the thing is, machines don't get bored, they don't get tired, they don't just sort of not bother for a day. So that's where this really comes into its own. Okay. So, next up, I'm going to give a few pointers for what, for common things you need to think about when you're writing these tests. So when it comes to identifying elements to interact with in your tests, Webdriver supports CSS queries of any kind. So you can go like, get me the div with this class name, and then inside that div, get me the button, and then like, and so on. But that approach leads to really brittle tests, because it means that like, some developer comes in and they go, oh, actually, what we're going to do is we're going to change that button. It's going to be a link now. And suddenly your tests break. And that might be correct. It might be that changing that button for a link actually did break the page. But it might not. And the key is if you kind of divorce your tests from the actual structure of the DOM, then as long as the functionality remains intact, as long as the functionality your tests are checking for remains the same, you won't need to keep updating your tests. So my recommendation is give every element that your test interacts with a data-test-id attribute. And that way you're not relying on the position of these elements in the document. You're not relying on like what text is in that button. And the other thing that's really good about this is it means that when you're editing the code, you can instantly see which elements are interacted with by a test. So you know, rather than having to wait for these tests to come back, which are pretty slow, they can take, once you get to a sizable application, they can be taking 20 minutes, half an hour, an hour to run through the complete suite. So rather than having to wait for that to know that you're likely to have broken a test, you can preemptively go, okay, I've just changed the behavior of an element that had a data test ID. Maybe I should go and see if see where that element is used in the tests, and check that those tests don't need updating as well. Next up, handling delays. So the first big problem you run into when you're building end-to-end tests is that things suddenly start taking time, and it's not always easy to kind of know how long a thing is going to take. And the easiest solution always feels like it's just like, oh, we'll just add a delay. Like, okay, the test is failing here because I'm like submitting the form and then checking that the form was submitted, but the form takes like a second to submit, so I'll add a 2-second delay and then problem solved. And the problem if you do that is twofold. One is you're making the test slower every single run because you've got to allow a bit longer than it actually takes. So every test run is as long as you allow. The other problem is that you're making your test really brittle because you don't want to allow too much extra time. So say the form takes a second to submit, you might be like, oh, we'll have a delay of 2 seconds. But then if the form takes 3 seconds to submit, your test suddenly fails, and you probably didn't want your test to fail in that scenario. So a much, much better approach is to just poll until the condition is met. So just keep checking, keep checking, keep checking, keep checking, and then you can see that the condition is met, and you carry on. You can have a timeout then still. You still want a timeout because you want your test to eventually fail if the outcome never occurs. But you're then much more flexible about what you set your timeout to. You can set a timeout of 20 seconds, 30 seconds, because 90% of your test runs are still going to finish in 1 or 2 seconds, and it's only going to be those extreme cases where something else is running on the same server and it all runs a bit slower than it normally does. There is, of course, the issue of like maybe you actually want to know that your site has suddenly got 20, 30 seconds slower. But I would say your end-to-end tests are not the place to do that. You don't want to be using timeouts in end-to-end tests to pick up performance problems, because it's really hard to know in your end-to-end test if it fails. It's really hard to know whether that was because the site was running too slow or because the site was broken. You want a test failure in your end-to-end test to mean your site was broken, not your site was slow. There's lots of other tools out there for monitoring performance and making sure that that doesn't degrade over time, but that's not the subject of this talk, and it shouldn't be the subject of your end-to-end tests. Next, really complex elements. Sometimes you're writing like a fairly high-level test, going through a big workflow, and you've got some weirdly complicated element. And a good example of this is like React Select. So the React Select element is a custom select element. To the user's eyes, it's pretty simple. It's just a drop-down like any other. They click on it, it opens, they click on the option they want. To your tests, it's really complicated, because to your tests, it's like a big collection of divs and buttons and spans, and then when you click the thing, another big collection of divs and buttons and spans appear, and then like it's scrollable, but it's virtualized, so not all of the elements exist yet, so you have to like scroll, and then the elements start to appear. It's hugely complicated. Now, if your goal is to test that the React Select element works as intended, then sorry, but you're going to have to deal with that. It's just life. But if your goal is to test that your application works, and you're willing to assume that the React Select element itself is well enough tested, well enough maintained that that works, then there's a better approach. You want to cut that React Select element out. You want to stop worrying about it in your tests. Nice thing about React is we have lifecycle hooks, we have state, we have all sorts of really powerful abstractions to use. And we can use those abstractions to our advantage here. So if we use a combination of component did mount and component will unmount in the select element, we can tell when the element appears and disappears. If we give it a data test ID, as we normally would, what we can do is expose that element on the window object. But we're not exposing the DOM element with all its complexities here. We're exposing the instance of the React component here. So that component has access to the props, but these are the props that were passed into the select element, to the React Select element. And then if we're gonna set that up in component did mount, we need to tear it down in component will unmount, because otherwise we're going to leak these select components every time they're added and removed from the document. So that's really important that you get the pairing there if you're going to take this approach. If you're going to ever add anything in component did mount, you need to remove it in component will unmount. Then the other half to this is like, how do I use that in my test? Well, one of the APIs that Webdriver provides is an ability to execute JavaScript in the browser. Effectively, it's eval, but remote. Remote eval doesn't sound like a good idea, but anyway, it's fine in this context. So what you do is you pass it a string of JavaScript, and you also pass an array of arguments, which you can access within that string. So for example, if we're using something like React Select with this approach, we can have a get select value that takes the ID of the select we want to get the value of, and then we can return the result of running this code in the remote environment. So we can just get hold of that select, the actual raw React select class, and then get access to props.value within that. And then when we come to set the value, we can just call on change remotely. And this takes away all of the complexity of trying to deal with that select element. If all of your tests look like this, then you're not really doing end-to-end tests. At some point, you're just writing a new weird integration test. Like, I wouldn't recommend that you do your end-to-end testing by like exposing the dispatch method of Redux and then only ever doing any actions by like firing Redux actions, because your users don't sit there and like open the console and start typing dispatch new action, etc. Like, they click on the buttons. But when you've got a test where like you're able to write 90% of it in a nice way, actually clicking the buttons and interacting with the page, but you've just got one element that's really fiddly, one bit of it that's really fiddly, this can be a nice way to cut out the fiddly bit and go, like, I just want to write a test. And the key to this is that it matters much more that you get something written, some tests written, than exactly what those tests are. So it's about motivation. If you don't have the motivation to write tests, then you're not going to write them. Okay, so that demo was in fact a video. So I don't think I fooled anyone, but I think it's now time for an actual live demo if possible. So I'm gonna, because this is not my computer, because we had some issues with the video, this may go poorly. Hang on, right. How do I undo the mirroring? Is that, because I need to, make it mirror rather. Displays. There. Okay, and then, yeah, I can do. Right, okay. Okay, I think we're good. Cool, yeah. So I've got a React app here. Yep, sorry. So I've got a React app here. It's just a basic React app that I'm going to start. And in a second, it will load up. It's going to take a moment to build. So this is just a basic React app just for demo purposes. And it lets you type in a string. And you can click the reverse button, and it reverses the string. And of course, you can click it again to get back to the original string. So what I want to do now is replicate those steps, but in an automated test. So I've got my blank test file. Oh, my not blank test file. Yep, okay. So I've got my app here, which is the... yeah, I need to make a lot bigger. Is this going to where? Yeah, okay. Yeah, I'm sort of starting to feel like, has anyone watched that film, The Men Who Stare at Goats? It's sort of, yeah. Right, okay. Yeah, as long as I just use my mind, the keyboard works correctly. But none of the characters look right. It's all good. Okay. So I've got my element, there's the state, and there's a couple of event handlers. But what really matters from the point of view of writing the tests is that I know what the functionality is, and then I want to look at the actual elements that get rendered. So here we're rendering an input and a button, and those are the two elements that I interacted with when I was manually testing this application. So those are the elements that my test is going to interact with. So I need to give each of them a data ID. So if I just give the input an ID of value, and the button an ID of reverse, because that's what it does. Then in my test, I can import, oh God. Oh, it's one of these, there we go. That's true, I could. And then import cabby. Hopefully there's not too many more special characters. So yeah. So I'm importing assert just so I can do assertions. I'm importing cabby. Like I said, there's a synchronous version and an asynchronous version of cabby, depending on how you want to write your tests. So the first thing you do is you create a driver object, which you specify the remote. So I'm going to use taxi rank for now, because it's just the easiest to get set up. And I can set up a base which sets the kind of default URL that everything else is relative to throughout the tests. So that means that if I wanted to change this test to run against the production version of this site, I'd only have the one location to change. I can also set debug to true, which will just log out all of the sort of actions that happen that get taken against the browser. So next up, the first thing I did when I did my manual testing was get a reference to was to click into that input element. So the first thing I need to do writing my automated test is get a reference to that input element. So if I get this input equals actually first I need to load the page. So first up I load the page. Next up I get a reference to the input element. And you'll notice I'm getting really good autocomplete support here, which is because cabby has TypeScript definitions, and it also has flow definitions. So regardless of whether you use TypeScript or flow, you'll get both really good autocomplete and proper type checking before your test runs, which really helps because the test is so slow to run. You really don't want your test to fail on the last line because of a typo. So this get element is just taking a CSS selector, which means I can use that data test ID just by passing the exact same CSS as I would use to select the element that has this attribute with this value. And I can use input.send keys to simulate typing into the input. And first, actually, I'm going to check that the input starts off as blank. So I'll assert that the input.getAttribute value is the empty string. And then after that, I'll type in hello world. Then I need to get the button, because I then got the button and clicked on it. So I'll do const button equals driver.activeWindow.getElement. And I called it reverse. And then I can do button.mouse.click. And that's going to click the button, which will submit the form, which should reverse the text. So next up, all I need to do is check that the text was actually reversed. So if I just repeat my assertion, but this time it should be DLROW space OLLEH. Good. So hopefully that should all work. The only thing that's left to do is close the browser, which is driver.dispose. So I'm leaving the application running, and I'm going to open a new tab. What's that? Okay. Yeah, right. And then, yep, thanks. So then I should just be able to run my test. Yep. How's that? Is that better? Yep. Okay. So that ran my test, and I can see, because I've enabled debug, I can see it's all actually working. But if I break the application now, that assertion will fail. Now, that's still running in my fake browser, taxi rank. But if I want to change that to run in a real browser, first I just change this remote to Chrome driver. And second, I open another new tab. And I've already downloaded Chrome driver, which is, you can literally just download the binary for the appropriate platform and then run it in the background. And this just is a Webdriver server that sits there and listens for connections and will run Chrome for you. So now, when I run the test again, it should look almost exactly the same, but it's going to run Chrome in the background there. So you saw just behind the screen, hopefully, Chrome like pops up for a second, does everything, and disappears again. And it's so quick, you barely see it with something like this. And because it's promises, if you wanted to write the same code using async code, all you'd have to do is stick it all in an async function and add a load of awaits all over the place for every method call, and it would work exactly the same. So there's very little change needed, no relearning everything from scratch if you do want to write your codes, write your tests asynchronously. So that's me. Thank you.
So when you run headless, what do you actually test? Because the browser has an API that the driver talks to, right? So
right.
What happens when it's headless?
So when it's headless, it's still rendering the page internally. It's just not rendering it to the screen. So you're testing all of the same stuff, but the aim isn't to sit there and watch the test. The aim is to have assertions in your code that are checking that the right things have happened.
Right, but how can you validate that the right thing happened if you don't call the API on the browser? I never really managed to wrap my head around this.
So there's lots of ways that you can verify that the right thing has happened. So for example, if your test is posting like I don't know, imagine you've got like a Twitter-like interface and your test says like go in, write a new tweet, like press save. Like one way you can be pretty sure that that has at least mostly worked is that you can go into the database and see that a new record was created with that new content. So that lets you know that that something has definitely happened. But the other thing on this point as well is you note that when I wrote my test just there, that I didn't just like have it type hello world and then press the button and then end the test there. I also then had it read back the value from the input and check that that value had in fact been reversed, that the action had taken place. So I know that assert works because I use it in my other tests, and I can also, I could break something and check that it fails. So for example, I could update that test. In fact, if I don't update the test and I just change the app code and I go, actually, you know what, let's just delete the whole bit that does the reversing. And then I rerun my test, which is here. And what I should see is it will fail. Yeah. So I get an assertion error here where it's saying, well, we expected there, and we got hello world, so something must have broken. So by deliberately making the assertion fail, you can check that your test must be checking something.
Okay. Another question, why do you set the attribute and not just set the ID of the element to identify it?
Right, so the reason I'm using a separate attribute and not the ID is, one is that you can have multiple elements with the same data test ID, but you can't have multiple elements with the same ID. And because the system does, so you can query an element and you can then say, get me the child of this element that matches this query. That can be quite useful in that you can have like the same kind of complex element that has multiple children. Each of those children has a data test ID, but then you can reuse that complex element multiple times, give each of those usages its own data test ID, and then it's possible to go, okay, well I want the like submit button within this form, or I want the submit button within this form, or I want the submit button within this form. Whereas if you give everything an ID, then they're all kind of global. So yeah, that's the main reason. The other advantage to doing it that way, although I haven't actually got around to doing this myself, is it should be relatively simple to write a Babel plugin to extract those data test IDs and just delete them all, which would then let you kind of go, we don't want to ship these to production ideally. But the overhead's not massive, so I haven't got around to doing it. But it's something I want to have the option of doing eventually.
How do you make the tests reproducible? Like if you have CRUD operations with your database or whatever?
Yeah, the approach I've taken to that is always like start the test by attempting to get everything back to a consistent state. So I've tried both ending tests with like cleanup operations and starting them with cleanup operations. I found it's much better to start with the cleanup operation, like start by assuming nothing about the database, about the state of the database, and begin with a load of stuff that has nothing to do with Webdriver and is just like, okay, are there any like records left over from previous test runs? If so, delete them. Like, do I need any records to exist that don't exist? If so, create them, and so on. And it's a bit manual. It's not ideal, but I haven't found a better way of doing that particularly yet. The other option, I suppose, if you have a database, an environment that supports it, would be to just throw away the entire database and recreate it from scratch. And start with a blank database each time. There's a question at the back there.
Hello. Any strategy you can recommend if we run a lot of A/B tests at the same time and you need to test with end-to-end tests?
A/B tests, was that, sorry?
Yeah, I mean, like we run a lot of A/B tests and sometimes they change the behavior of the website and we still need to maintain the end-to-end test.
Yeah, I think it's up to you. You have to do this as part of when you're setting up your A/B testing infrastructure. This is something you have to think about. And I think there's two things here. One is if your test isn't like attempting to test one specific version of the A/B testing, then you need to do something to make sure that those A/B tests are stable. Which could be that when you say like, okay, when we run our like server in test mode, then like default all A/B tests to like the first option, which then at least makes sure that your tests are consistent, but it obviously does mean that there's one set of each A/B test that you're like not testing. And then the second thing, if you are attempting to actually specifically test that A/B test to make sure that this variant of it works correctly, then make sure that the test explicitly says like create a new user, put them in this group of the experiment, and then run the test. So make sure that it's always kind of locked to one version is my advice for that. And if you've got the kind of infrastructure and time and what have you and resources, then ideally run every test by default against both versions of every A/B test. But obviously that becomes like expensive rapidly as you increase the number of tests you're running.
Any more questions?
Cool.
No?
Thank you.
Thank you.